Hello, my name is Steve Loisel, and I'm the Southeast Automation Specialist for IDEC. Today's class, we're going to go over indirect addressing. Um, so this is an advanced block of instruction for programming. It's a little convoluted, but once you get into it, you'll understand how easy it really is. But it's very, very powerful. So let's begin. So why use indirect address? Many times in a PLC programming, we want to create a single function that can be used for many different cases. Indirect addressing can be a powerful tool when you're generating recipes. It can simplify not only your ladder program, it can also simplify your HMI program by allowing one entry point for data. It can simplify communications, sending one word instead of 16 coils. And it can simplify calculations by allowing you to program the math calculations one time and change the variables by indirect addressing in many locations. So there's two types of indirect move. One is the indirect word move, and the other one is the indirect bit move. And we're going to go over both of them today. And they're very similar to each other. So what you have is it's basically just a move instruction, but you have a source and an offset, and you have a destination and an offset for the destination. And what that means is in the indirect move pop-up screen, when you program this, you'll have S1, which is the data register where you want your move to start from. That's where the PLC is going to start looking at data. Now this offset here, or S2, this is how many data points you want to skip or offset your move instruction, what you want to read from. And then destination is where you're going to put the information that you're moving from D500 to D600, and D400 is your offset for your destination. It'll make a lot more sense once we start programming it. So how the offset is used. If I use, and I'm going to use my example up here, if I use D500 and say I have 5 in this offset right here, what it's actually going to start doing is moving D500 plus whatever's in S2, and if the value in that data register right there is 5, it'll move D505. It'll repeat it 5 times. So it'll move D505, 506, 507, 508, 509. And it'll move it into D600 plus D2. So if, say, there was a value of 5 in D400, it would move the data from here, and it would move it into D600 plus this offset. So instead of putting it in D600, it would put it in D605, 606, 607, 608, 609, etc. And the destination, I just explained all that. And also the destination also has an offset to it also. So this box allows you the repeat up here. If I have repeat checked here and repeat checked on the destination, it'll basically copy 5 words at a time because there's a 5 up here, and it'll place 5 words at a time inside this instruction. So indirect move bits work basically the same way. You can have dynamic moves in the bit move also. Means you can use a counter, current value, or you can use a data register that changes all the time depending on where you want to move the data to, which is what we're going to do here in just a few minutes. So let's begin with a few sample runs of code to give you a better idea how powerful these are. pick up our ladder here. Now, what I'm going to do is I'm going to program a recipe, basically. So on my HMI screen, I have a place to put a recipe number. This is a data input, right? And I could put input data here for the number of boxes per layer. Say I'm going to do a palletizer, right? And I want to, it's an automatic palletizer, and I need to tell the palletizer how many boxes to put on each layer, how many layers to put on a pallet, how many times to wrap the layer with saran wrap, and the conveyor speed that I want it to move in. I mean, there could be a lot more. I'm just going to use 5 as my example. So the first thing I'm going to do is I'm going to program a fake vid in here to set my recipe. Okay, what recipe set number I want to set in. Okay, and I'm just going to use a move instruction, and I'm just going to move D500, and I'm going to move it into D500. Basically, all I'm doing is just showing you with this line of code, which makes no sense whatsoever in the real world. I'm just going to show you where my recipe number is, and that I'm moving, and that the recipe number changes in D500. And I want to be able to do this either whether I'm setting it or I'm going to load it, the recipe. So I'm going to put 2 of them in there. And I'm just going to put a single output in line with that. Okay. So this code would not really exist in my PLC system. I'm just putting it there to take the place of this input right here and this input right. Those 2 bits are these inputs right here on this button, and the data that I'm writing to is in that recipe number right there. So the next thing I'm going to write is a script, and I don't have to write this in script. I could write this in I could write it in ladder if I wanted to. It's just easier to do in script, and it makes my program much smaller and much shorter. I'm going to put another bit in here. I want to offset the work whether I am loading or unloading the indirect move. Okay. I'm going to put a script in here. I'm going to call it script number 1. I'm just going to give it a data register to go to. This data register is there to hold any errors or any problems with the script. Now I've already written it, and basically what I've written, in case you can't see it, is this right here. I'm going to take whatever's in D500. I'm going to multiply it by 5. I'm going to add 1 to that, and then I'm moving the entire answer into D400. Okay, D400 will be my offset. Okay. Okay, so that's set. So the next thing I'm going to do is I'm going to set my recipe, right? So I'm going to use another normally open contact. I'm going to call this one M2, load recipe. I'm going to put a single output up here. So it only happens once every time it changes states. And then I'm going to put my indirect move bit in here, or function in here. Okay. So what I'm going to do is This is linked to D500. This recipe number right here is D500. The number of boxes is linked to D501. The number of layers per pallet is linked to number 502. The number of wraps is linked to data word 503. And the conveyor speed is linked to D504. Okay? So I'm going to put D500 in here. D500, which is my recipe. And I'm going to want to repeat this for 5 words because I'm going to copy that whole recipe number. Now, I'm not going to use an offset on my load because I want to copy 505, 501, 502, 503. I mean, 500, 501, 502, 503, 504. I want to copy that, so I don't want to offset. But I'm going to move them into D600. This is my recipe storage area. And I'm going to use an offset on this depending on what recipe number I'm using, okay? I'm gonna repeat that, and I want to copy because I'm going to copy 5 words per recipe, okay? And that's all there is to it. Oh, sorry about that. I just put a 0 in there to show you that I was putting a 0 in there. So that's all. That's all there is to that, okay? So let me show you how this works. It's very simple. I'm going to go online and go to simulation, okay? Now I've already got. Let me take that simulation for just a second. Let me move this to the center of the screen so you can see it. There we go. Put it back in simulation mode. I'm going to go to my word move, okay? I've already made this custom monitor. Let me remove all the data out of here. Empty this. Let me empty this out. Okay. So as you can see, I have nothing in D500 right now, okay? I have nothing in my boxes, nothing in my layer. So from my HMI here, I'm gonna put information into my PLC. So for the recipe number, I'm gonna make this recipe number 1. In recipe number 1, I want 30 boxes per layer. I want 5 layers of boxes on my pallet. I want to wrap it 6 times with the wrapper, and I want the conveyor speed to be 40 hertz. Okay. So I've loaded all that in my PLC, and I'm about to hit this load recipe button. So I hit the button, and you'll see that when I hit the recipe button, my script went to work also. And it put a 6 in the value for D400. So my offset is now 6. So when I use this instruction here, which is D500, no offset, D600, and it's going to put it in D600 plus whatever's in D400, which is 6. It'll put it in D606. Okay, so it's going to put it where I have recipe 1 label. It'll put a 1 in D606. It'll put a 30 in D07. It'll put a 5 in a D608. 609 will have 6 in it. D10 will have 40 in it. Okay. So I hit the load. I'm going to hit the button I'm going to hit right now is this one right here, the load recipe button. And you'll see that it loaded exactly what was in these 5 files into these 5 files. Okay. Now I could use the same instruction again to load another recipe. I just got to change the number to it. So I'm going to change this number to 3, the recipe number to 3. Okay. This is going to be recipe number 3. And I'm going to change it to, I want to put 25 boxes per layer. I'm going to have 6 layers. I'm just going to wrap it 4 times this time. And I want the conveyor speed to be 45. Okay. So when I hit the set recipe, it's going to change the value in D400 to D16. I mean, it's going to change it to 16. It changes to 16, which means when I hit the indirect move down here, it's going to move whatever's in D500, 501, 502, 503, 504, and 505 into D16. I mean 616, 617, 618, 619, and 620. So I just hit the load recipe button, and you'll notice it moved it all down here into the recipe number 3. Okay. Now I can add more I can add as many recipes as I want. I just have 3 programmed now. I'll load recipe 2 now. I'm going to load recipe 2. I'm going to change that to I'm going to change 40 boxes and 3 layers and change that to 3 and change this to 60 hertz. Okay, from my screen on my HMI. Now I'm gonna change the. So now you can see I'm gonna put it in recipe number 2, but it's gonna start at 511, D511 or 611. I'm sorry, 611, and D611 is where recipe 2 starts, and that is the reason. The reason that's going to happen is because of my offset. So if I go back down here to my recipe, because I have it loaded, I've got it loaded with the correct recipe number. If I change the state, it now loads recipe number 2. And so that's all fine and good. I've got all these recipes and I've got all the data files put where I want them. All I need to do now is use another indirect move. Take this out, take it out of simulation. I'm gonna create another indirect move. M3. Another single output and an indirect move. But this time I'm going to take whatever's in D600 and D400, which is my offset, and I'm going to move it into D100, which is my working recipe number. And that's just a file. That's just a data register that I know I'm not going to have any numbers in. So I'm going to repeat this because I want to get 5 words every time I do this. I want to get 5 words. Okay. So I hit repeat on this on the storage. Repeat on the destination, and I'm going to do it 5 times. Okay. So now the way this works is, say I want to. simulation mode. I want to move recipe 3 into my working file because that's the recipe that I want to work with right now. 3. Okay. So now you'll notice because there's a 3 in there, there's 11 in D400. That's my offset. So it's going to go look at D611, and it's going to move that information to D100, and it's going to move 5 words at a time. So here's on the bottom. This is my working file. You'll notice there's nothing in D100 to D105. And then if I hit the set recipe function, I move that data into my working recipe right there. And I can change this recipe to move. Now I can move. Now say I want to run recipe 1. Enter. And I go down here and I load M3 again, and it's going to change what's in D100 to D105 to the recipe 2 here. It's going to change it to these 2, 40, 3, 3, and 45. Two, 43, 3, 45. It moved recipe 2 there. So that's how an indirect move works. Now, do you guys remember Friday? I hope you came last Friday's webinar. Elias went over user-defined macros, and if you design your user-defined macro with all your bits in one location, all your outputs in another location, in sequential order. If you're using M0, M2, M0, M1, M2, M3, and then you're using Q1, Q2, and then you're using 5 data words, D100 through 105. You can see how using this indirect move and indirect bit move, which we're about to do, you can load those user-defined macros. So you only have to create it one time in your program, and then you can use these indirect moves to populate that user-defined macro depending on what recipe you're running or what pump you're running. You can also go through and put as many user-defined macros in your program as you want. Say you got one that runs your palletizer labeled 0. You can use 0 as many. You can use that user-defined macro that runs the palletizer as many times as you want, or you could just do indirect moves into one user-defined macro. It's 2 ways of doing the same thing. Okay, so let's close this. So what we're going to go over now is your indirect move, okay? Bit move, an indirect bit move. And it works very, very similar to the indirect word move, okay? So we're going to put another bit in here, another normally open bit after I take it out of simulation. I'll put M6 in here for this one. This is going to be a bit move. I'm going to put a SOT in here. So it only happens one time every time that bit comes on. So I'm going to use the IBMV, the indirect bit move. And you'll see it uses the same format as the indirect word move. So I'm going to take M900, which is just a random it's a random set of bits. I'm going to repeat this. I don't want to use an offset with this, okay? And I'm going to move this into D300. Repeat this. I don't want to offset for this one either. I just want to move these in there. I'm going to do it 8 times. Okay? So what this is going to do when we set it up, there we go. You can see there's no values in M9, 901, 902, 903, 904, 905, 906, 907. Okay? And there's no values in any of the what it did was it took D300 and it broke it out into bits. Okay? That's D300, bit 0, D300, bit 1, D300, bit 2, D300, bit 3, D300, bit 4, and so on. So let's say that I have a memory location and I have M900 is on, M901 isn't, M902 is on, M903 isn't, M904 is on, M905 isn't, M906 is on, and M907 is on. Okay? When I turn this instruction on, it's going to move these bits into this word and break it out into bits also. So turn this on, and you'll notice that it populated the word with the bit numbers. Bit 300.0 is 1, 300.1 is 0. It copies exactly this register and puts it in here. Now, you can offset this. You can tell it to move it in different locations. I could have moved this into bit. I could have moved it into bit 300.08 instead. You know. But why this is important? Like, so say let's just pretend that this is in that this bit right here and this indirect move is in PLC 1. Okay. I'm going to move whatever's in my memory locations in M900 through M98 or M907 and put it into data word D300. I can then go to my Modbus table and I could send D300 to another PLC or another device that talks Modbus that I needed bits to control in. And then what we're gonna do is I'm gonna pretend like this is PLC 2. This is a these are gonna be the bits received from PLC 1. So this is where I'm gonna break out this word back into bits in a different PLC or a different location. So here's an indirect move bit, or indirect move, bit move. So I'm going to take D300, no offset on this, and I'm going to move it into Q60. I want to repeat that, repeat it. I'm going to do it 8 times. And I do not want to have any offset on this because I want to move whatever's in D300 or 0.00 into Q60 and then 301 through into Q61. So if I go to simulation mode, go to custom bat monitor, bit move here. You'll see there's nothing in any of these outputs right here, okay? But if I turn this bit on, M6 on, it'll move whatever's in D300. You'll notice there's nothing in D900 right now. It'll move whatever's in D300, and it'll move it into these individual outputs. So basically what I'm doing is from one PLC, I'm taking memory locations, I'm moving them into a word, I'm transmitting that word to another location, and then when it gets to the other side, it's received in the other PLC or other device, I'm taking that word and I'm breaking it out into bits. So when I turn this on, this will be copied into these outputs right here. Uh-oh, what did I do wrong? Oh, I didn't set them? There we go. And then there we go. Do I have am I overwriting this somewhere? Oh, I am overwriting it. I'm sorry. I'm not using the right instruction. This is the instruction I should be using. I'm sorry, guys. There, I'm sorry. I had, here, I'll show you again. I was using the wrong instruction. I'm sorry. I should have moved it up so I could see it too. So we'll start over again. So I'm going to take M9. I'm going to turn these bits on in a PLC. Okay. I'm going to transfer these to a word. They're transferred into a word, and then I'm going to transfer it from a word back to to outputs. And you'll notice that now all 3 sections, all the M900 through 907, all the word, and all the output bits are all the same. You can use an offset with this. You can use a counter preset to tell it to load a specific bit at to a specific output. I can use D900 and I could put a counter in here. A counter, if I had a counter in my program, I could put a counter in here that tells it to move whatever's in M900 and whatever the current value of the counter is into D300 and whatever the current value of the counter is, and it'll move the bits it'll offset the bits as the counter increases. Or I could use an offset that I write in a script or I put in the ladder, but I don't have to write 1-to-1. I just wanted to show you how it works. So I'm just taking one set of numbers, one set of registers, and I'm moving them into another set of registers basically. And I didn't have any offset. I just wanted to show you how it works. So you can't use an offset for these. So that's all I have for this part of the class. Let me see whatever questions we have here. So can indirect move instructions use float, double words, long words, as well as words and bits per 16-bit word? So in the indirect move instruction, the indirect word instruction can move floats, double words, long words, as long as the receiving file can hold the information. And you could do 16 bits per word. Yes, you can. You can move. Actually, you can move. You can move 16 times 99 all at one time. You can, because you can move 99 words at one time, or 99 bits at one. You can move 99 words. So I could load 99. I can load 99 bits into how many words that would be, which would be so if I take 99 and divide that by 16, I could use 7 words. I could put 99 bits into 7 different words. Yes. In your indirect move instruction training example, offset goes 0 and bits. Can indirect move also have a negative offset and go? Can they have a negative offset? If you put an integer in your indirect move and it was a negative number and you weren't overriding a file somewhere, I don't see why it wouldn't work. I've never tried it with a negative number before. So it goes from in a move bit, it moves 0 is always the least significant bit to the most significant bit. So it goes where you tell it to go to. If it starts at 0, it's going to move it in the least significant bit to the most significant bit. And yes, you see, how can a script block be used to receive and extract Excel? Okay, that's not really part of the class, but that's a completely different class. How can a script block be used to receive and extract Excel CSV file and text data values? That's way more advanced than this. Sorry, I'm. You got the whole gambit of stuff you want. There you go. Okay. One example of an indirect move I used. I had a palletizer when I worked at Clorox. That I had to each box was represented by one word. And in that word, there were bits that were on and off that performed functions to position the box on a layer, on a sheet, pallet sheet. So, like, one box would come in and it would turn it 90 degrees, or then a box would come in and it would send it to one side of the conveyor system, and another box would come in and it would send it to the right side of the conveyor, and then the fourth box would flip up 90 degrees, and it would load a line of boxes like that, and then it would push the boxes out, and then after it got the number of boxes on the layer, it would move that onto top of a pallet, and then a sheet would come back down and it would move another layer of boxes and position them correctly. And I used indirect moves because we had I think 18 different patterns that we had to, that were boxes were on, and so I had 100 words in each pattern. So I had to use indirect moves from the recipe, and I moved them into the working file so that when I wrote the program, I wrote it for just one set of bits and one set of integers, and then as I needed those integers to change, I just moved new recipes into the working file. So that's a way of using it, and it basically the most common way I could think of using an indirect move is for recipe movement. I used only 5 words and a few bits, but in a recipe, you might have 30 or 40 words in a recipe, or in 100 bits. But so that's what an indirect move is for. It's so that it's for ease of programming. It's so you don't have to keep on repeating programming that you've already done. You could just move files around and move them into locations where you need them. In the example that I used here, if I wrote a program to control this, I would only have to write using N100. I wouldn't have to write it N100 and then use it for another, like say N200 or D200 was where my second recipe was, and D300 was my third recipe, D400. I wouldn't have to keep on using and have to rewrite code to cover all those recipes. I could just move that whole array at one time into a working recipe that I could then use to program. So I could just write one program instead of several and move information in and out of the program as I need it. That's what they're basically for, though. And Doyle, the question you asked about the using a script to receive and extract Excel CSV file text data values. I can write you an example of that and send it to you personally instead of because that's way above what this class is for. So that's all the questions that I have right now. So if that's it, that's the end of the training for the day. Thank you for joining, and there'll be another one tomorrow on. I'm not exactly sure what the subject is. I didn't look at the schedule. I'm sorry. But there'll be another class tomorrow, and I hope you guys all join it. Thank you.